Hi there everybody, this is lesson 1.2.5. You'll need your resource pages out. You'll need the 1.2.5 resource page. So if you don't have that out, go to pause the video and grab that. You will need it. We're going to talk a little bit more about symmetry today, and some of these basic shapes that we started working with in yesterday's lesson. Remember the quilt lesson that we did at the beginning of the year? You made a quilt design that had reflection symmetry, and we said that an object had reflection symmetry if you could fold the paper and so that both halves kind of matched up. And the fold that you made, that was a line of symmetry. Well, it also works if you simply reflect the shape over the line and it looks exactly the same. It's another way to kind of define what reflection symmetry is. So what we're going to do is we're going to go through some of these shapes and draw any lines of symmetry in the shapes that we can see. So this regular hexagon here, for example, has a line of symmetry here. It has a line of symmetry there. It has one there. And it has some more. It's got them here, there, and one more there. Altogether, that is 6 lines of symmetry. We can reflect that regular hexagon over any of those 6 lines, and it would look exactly the same. The kite right next to it, this is called a kite. It looks like a kite that you would fly outside, and that's what they look like. That's what we call them in math, but that only has one line of symmetry. That is the only line that we can reflect both sides of this kite over and have it look exactly the same. The rectangle is going to have 2. Now some of you might try to draw this one, but if we reflect this rectangle over that diagonal line, this point would end up here. It doesn't match up with one of these other 2 points. So that is not a line of symmetry. The rectangle only has 2. If you'd like to give some of these a try on your own, go ahead and pause the video now and draw the rest of the lines of symmetry. I will go through them again as well and show you the answers in a second, but you can so that you can see how you did. So go ahead and pause the video now and draw the lines of symmetry in the rest of these shapes. Welcome back. Here are the rest of the lines of symmetry. As you go, if you find a mistake, go ahead and fix it. The equilateral triangle has 3 lines of symmetry. The trapezoid has none. There are no lines here that we can reflect it over so that it looks exactly the same. The square has 4. The isosceles right triangle only has 1. That's the only line you can reflect it over. The circle is a little odd because there are actually infinitely many lines that we could draw that are lines of reflection for a circle. As long as the line goes through the center of the circle, it's a line of reflection. So we could reflect the circle over that line, over that line, over that line, over that line, over that line. Any line that goes through the circle, we can reflect the circle over and it would look exactly the same. So how do we want to write that? You know what, let's just leave it blank for now. Let's write any line that goes through the center. So again, let's just make sure you write any line that goes through the center of the circle is a line of symmetry. For the rhombus, we've got 2 lines of symmetry. vertical and a horizontal one. The quadrilateral doesn't have any. The isosceles triangle here has one, just right down the middle. The scalene right triangle. Now, a right means that it has a right angle. Scalene means that all the sides are different lengths, in case you were wondering, but that has no lines of symmetry. The isosceles trapezoid has one. The parallelogram has none, surprisingly. You might think that this is a line of symmetry. However, when you reflect this point right here over that line, it ends up over here somewhere. It doesn't match up with this. So it doesn't look exactly the same when you reflect it over that line that we drew. Same thing if we drew a line the other diagonal. It wouldn't look the same if we reflected it over that line. So no lines of symmetry there. And the regular pentagon looks like this. It has 5 lines of symmetry. They all go through the center. There are our lines of symmetry. Well, let's see what you notice about these. Which triangles, and this is question 87 here, which we'll just write on your paper. Which triangles have reflection symmetry? Take a second, write the kind of triangles that have reflection symmetry. Looks like the equilateral one does. The isosceles right triangle does. And the isosceles triangle does. The scalene triangle does not. Which other ones do we have? And the scalene right triangle doesn't either. Doesn't have any lines of symmetry. Which quadrilaterals have reflection symmetry? That's actually question C on 87. Which quadrilaterals have reflection symmetry? Now, remember, quadrilateral means 4-sided. So we're only looking at 4-sided figures. Regular hexagon is not a 4-sided figure, so that one doesn't count. Kite is, though, and a kite has lines of symmetry. So we'll put a kite. The rectangle does. Trapezoid doesn't. Square does. So let's put the square. The rhombus does. The isosceles trapezoid does. And these two, the quadrilateral and the parallelogram, do not. So let's put, I'm going to abbreviate that, isosceles trapezoid does have reflection symmetry. And last question is question D. Which shapes have more than 3 lines of symmetry? Well, the regular hexagon does. It has 6. Put regular hexagon, abbreviate a little bit. What did I say? More than 3? More than 3. Equilateral triangle has exactly 3, so that's not more. The square has 1, 2, 3, 4 lines of symmetry, so that's 1. And let's see, the circle obviously does. We said it has infinitely many, because any line that goes through the center is a line of symmetry. More than 3. We also have the regular pentagon. So we'll put pentagon. Those are the only ones that have more than 3 lines of symmetry on this sheet, of course. That's it for the video today. Hope you guys are having a great day, and we'll see you in class tomorrow.